This question comes from absolutely no one, but it should, because it's amazing. What would happen if we launched a toaster into the sun? Let's say you wake up one day, and you're tired of burnt bagels. You glare at your toaster, the red-hot coils of betrayal still glowing inside. And then it hits you. You're going to launch it into the sun. Take that, breakfast. Now, before you toss your toaster out the window and yell, "For science," you'll need a rocket. Because the sun is not just up there in the sky, it's really up there. About 93 million miles away. That's 150 million kilometers if you're using science units. And here's the first problem. Even though the sun looks big and close, it's really hard to hit. Like hitting the sun hard. If you launch something toward the sun, Earth's orbital velocity gets in the way. You're already moving sideways at 30 kilometers per second. Thanks, Earth. So your toaster will just orbit the sun, unless you cancel that sideways speed. To actually fall into the sun, you'd need to launch your toaster backward, fighting against Earth's orbit. That takes a huge amount of fuel, way more than launching into space. In fact, it's easier to launch a toaster out of the solar system than into the sun. NASA's fastest spacecraft, Parker Solar Probe, is using multiple Venus flybys just to get close. But fine. Let's say you've solved the problem. You've got the funding. You've built the ultimate toaster-launching space vehicle, probably with help from a billion-dollar crowdfunding campaign and a suspicious number of engineers named Steve. Your toaster leaves Earth. It travels through space for weeks, months, dodging space junk and cosmic radiation. It's just a brave little toaster, humming quietly, drifting closer to that giant ball of nuclear fire. As it approaches the sun, things get toasty. At around 3 million kilometers away, solar radiation starts to become a problem. The toaster begins heating up, fast. Solar energy here is over 6,000 times stronger than on Earth. It doesn't just feel hot, it is hot. Your toaster glows, melts, and vaporizes long before reaching the surface. In fact, anything that gets within a few 100,000 kilometers of the sun turns into a glowing vapor cloud. But let's imagine your toaster is made of pure plot armor and manages to survive the heat. It keeps going, and then it hits the sun. Except it doesn't really hit the sun in the way you'd hit a wall. The sun doesn't have a hard surface, it's a giant ball of plasma, mostly hydrogen and helium. So when your toaster gets close enough, it falls into the sun's outer layers, called the photosphere, and gets ripped apart by extreme temperatures, pressures, and magnetic fields. It dissolves into atoms and disappears into the roiling chaos. And that's it. That's what happens. But wait, is that really it? Well, yes. From the sun's point of view, your toaster is irrelevant. The sun is massive. It weighs 333,000 times more than Earth. Your toaster might weigh 2 kilograms. That's less than a single sneeze in solar terms. It's like dropping a grain of rice into a volcano and expecting it to notice. The sun will not flinch. It will not burp. It will not get any warmer. No solar flares, no explosions, not even a tiny ping. In fact, if you launched every toaster on Earth into the sun, all 900 million of them, it still wouldn't matter. The sun would just keep doing its thing, fusing hydrogen, radiating energy, and ignoring your kitchen appliances.
But still, we did it. We launched a toaster into the sun, and while it didn't cause a solar storm or change the fate of the universe, it did answer a very important question. What happens when humans get bored and have access to rocket fuel?
The universe is a big place, full of burning stars, swirling galaxies, and unanswered questions. And somewhere out there, a toaster is now part of that story. Even if it only lasted 0.0001 seconds before turning into plasma. So next time you burn your toast, don't get mad. Just remember, you could always send it to the sun. For science.